Hello everyone, my name is Gerhard Schleenstein and I will present the results of a Chilean pilot study where we compared citizen science methodology with traditional odor impact evaluation techniques. We did this within the DNOSES project with help from our friends and coaches from Ideas for Change. The studied site was a wastewater treatment plant which is located in the south of Chile, in a town called Los Alamos. The wastewater treatment plant there operated for nearly 20 years now and historically impacted 3 neighborhoods with approximately 1,000 homes. We have Villa Caupolicán neighborhood, Quintupiruca, which means searching for a home in the native language. It's a social home neighborhood, and another social home neighborhood called Villa Esperanza. Esperanza means hope in Spanish. Caupolicán neighborhood and Quintupirupa neighborhood are located north of the wastewater treatment plant and the pumping station, and are located within the predominant wind direction, as you can see in the wind rose. Major modifications were introduced in 2018 to the wastewater treatment plant. This included a technology shift from sequencing batch reactors to activated sludge, and the installation of odor abatement technologies, such as a scrubber at the pumping station and a scrubber followed by a biofilter at the wastewater treatment plant itself. We used the general DNOSES engagement model that actively involves the citizens, in our case represented by their own organizations. Actually, the site was proposed by the water utility, so the wastewater treatment operator also supported the project, and we also talked to the municipality as, let's say, the local government. For ourselves, we saw ECOTEC as a fourth stakeholder within the quadruple helix model. We started the project in December 2018, visualizing the problem together with the water utility. We did then a stakeholder mapping in June 2019, followed by talks to the citizens and their organizations until October 2019, where we started to frame the problem and design a pilot together with them. And then from November 2019 onwards, we started with the data collection until April 2020, and afterwards we did the data analysis. Well, the project then was interrupted by the COVID pandemic, and some steps of the project we are not concluded yet are pending, which is the co-creation of actions and the outcomes actually. Well, we used some traditional measurement and evaluation techniques, such as the assessment of odor annoyance with questionnaires, field inspections with the grid measurement. We did it from December 2018 onwards. For both techniques, we have Chilean technical standards, which are based on the equivalent German standards. We also did measurements of odor and gases in some sources of the wastewater treatment plant and the pumping station, but these results will not be presented today. The results for the questionnaire method. We did it, as I told you, in June 2019. By then, the purpose was not revealed to the people. We used only the core questions of the model questionnaire, and we had a total sample of 55 people, where we had to exclude some people due to implausibilities, which is all detailed in the technical standard, let's say. As a result, maybe you want to look at the satellite image. You can see that close to the wastewater treatment plant, there live highly annoyed people. On the north side, let's say. On the western side, at Villa Esperanza, we have people that are not annoyed at all, because most of the time the wind is not blowing in this direction. And we have at Quintupiruca like a mixed position. Some people are annoyed. medium annoyed, let's say, it's not so clear, and more far away from the source, obviously the, um, the people are less annoyed than closer to the source. We use this information to better focus our efforts on the citizen engagement, focusing on Villa Caupolicán and Quinto Piruca. We also, as I told you, did field inspections with our own qualified assessors. The assessment squares we defined followed a regular street grid. There were some restraints regarding some practices of the measurement, as the environmental permit asked for other things that the technical standard proposes. So what you can see here is, or are the results after 35 days of observation in field. We have 2 assessment squares that exceeded by far, I would say, the 10% threshold of frequency of odor hours. So eventually with this you might say, well, the problem is or the affected area is even smaller than we envisaged first with the questionnaires. With relation to the citizen engagement, we had like a strategy where we defined ourselves as an independent, impartial stakeholder. We thought that citizens would be willing to participate using the AutoCollect app, or we knew that there were old elderly people living there, or they had it's like social houses, they probably wouldn't have data plans, so we also provided odor diaries if necessary. We initially thought that the engagement would work best through their own neighborhood organizations. In Chile, these organizations are formal organizations. They are formal elected representatives of each neighborhood. Something like this, I would say in Germany, or at least in Europe, I think that this does not exist. And we thought of a house-to-house campaign organized by ourselves, where neighborhood organizations would fail. So within the first months or the first 2 months of data retrieval, we saw that actually our neighborhood organizations failed. One was not interested at all, and another one hasn't been elected in time. They were elected in January, and we started in November. And January, February is summer season, holiday season in Chile. So we needed to act rapidly to get these months covered by our observations. So we had to do the house-to-house campaign on our own. Unfortunately, our headquarters were located 700 kilometers away from the site. So we had to contract local people. This was not working quite well. So we asked the municipality to back our house-to-house campaign, which would have created more confidence within the residents. This was scheduled for March 2020, but was abandoned due to the corona pandemic. So you can see here our monthly observations. We had quite high observations in February, March, and April due to a strategic shift we had to implement. Yeah, the citizens didn't participate like in a non-organized manner quite well. So we had a strategic shift and we focused on community champions. To do this, we had like very interesting persons. This was a group of 8 to 10 persons, all women. Some of them had visited the wastewater treatment plant together with us back in the beginning of November. Some represented the directives of their neighborhood organizations, and we trained them on wastewater treatment plant odors. We took samples in the treatment plant and presented it to them. We also had a field olfactometer. We tested their olfactation capacity, let's say. We trained them in field inspection measurements. We walked together with them through the neighborhoods and sniffed odors and so on. And after that, we asked them to cover a 2-kilometer circuit twice daily, in the mornings and in the evenings. And so we could get like to these 3,000 observations, and this were like organized observations. They had a clearly defined circuit and a not so clearly defined time frame when to walk these circuits. As a result, we calculated the odor frequency as a percentage of all observations related to each assessment square. You can see here the results for wastewater related odors. All observations were associated to the closest node, and then as we would do it in the field inspection method, the assessment squares belonging to this node received these observations. The citizens were highly motivated, reported any kind of odor in 85% of the cases. Just in 10 to 15% of the cases, they reported no odors. This was also a problem with the Odor Collect app, which lacked a no odor button in the beginning. But what you can see anyway is the assessment square related odor frequency for wastewater related odors are much higher by far than the odor impact characteristics in terms of frequency of odor hours we determined ourselves. So we had to have a closer look on the data. We had a good time and spatial resolution. The spatial distribution matches with odor sources and preferential wind direction quite well. The distribution in time also matches with general dispersion conditions. When we had better dispersion during daytime, we had less odor-related, wastewater treatment plant-related odor observations. But still, lots of our observations were made in the mornings and in evenings with far worse dispersion conditions. Also, many observations for wastewater treatment plant odors reported rather low or very low intensities and close to neutral hedonic tone. So we plotted in a first hand the medium hedonic tone for each intensity category. You can see the graph there for wastewater related odors, urban odors, or nice odors. And we thought maybe we should weight observations to get to more reasonable or comparable results, let's say. We did this by using, let's say, like an annoyance index as proposed by VDR 3883 Part 2. These technical standard ask citizens directly for annoyance, but our autocollect app retrieves hedonic tone and intensity. We saw in the previous slide that hedonic tone and intensity are probably or relatively dependent variables. So we thought we could use only odor intensity and associate it like to an annoyance category from the VDI 3883 with the corresponding weighting factor. And we did this calculus, you see the equation there, again assessment square related, having the following results. By numbers, these index numbers now are closer to the percentages of odor hours. So these are, we said, okay, it's annoyance index, but you might call it also a weighted odor frequency index. And the index values are higher during summer, going down in spring. This may be related to lower temperatures, may also be related to different types of wind direction distribution, and also may be related to the use of wood for heating purposes. So you have these combustion odors which mask probably wastewater odors. As the conclusions, the DNOSES methodology required considerable resources and relied on proper engagement strategies, where we failed a little bit, I would say. Citizens panelists have proven to gather observations in a high temporal and spatial resolution, certainly with a kind of overmotivation probably, we don't know. The data collection method in this case study can be considered as a hybrid one, something in between field inspections and repeated brief surveying. And we obtained reasonable numbers by a kind of odor annoyance index that weights odor observations according their intensity. What were the outcomes for the water utility? Well, they got a better understanding and a better contact to the citizens. We could identify better odor sources, especially the pumping station in that case, and we could focus better complementary studies on odor emissions. Again, odor was not the only issue. The citizens talked about noise. They had issues with the water quality of the receiving water course, response time of the water utility to citizen requirements. So all of this together, well, we didn't finish the project, but we tried to get to actions where we have like a better governance model of the other issues and a better understanding of the requirements of each stakeholder. Thank you for attention, and let's hear your questions. Thank you.